Okay, so this is a question number 2 on week 15, heat of formation. So heat of formation is delta HF, and typically the standard state, that typically means that 1 bar condition. And this is a very important thermodynamic quantity that can be tabulated, and you are seeing an example here. So let's read the problem first, which is on hexane, C6H14. So hexane looks like there are 6 carbons, and then they are all saturated. Okay, so this is a liquid compound made out of carbon and hydrogen. So in organic chemistry term, this is called hydrocarbon. So this is a common compound that organics can be obtained from the petroleum sources, and we are using for organic solvents and making into different forms. And here's one simple equation. Hexane react with an oxygen, also called it as a burning, and then you produce a CO2 and H2O, which is the ultimate oxidized form of carbon and hydrogen. And so they wanted to calculate delta H reaction. Okay, so the bottom line here is, because the reaction was written in that way, it is essentially delta H formation of product minus delta H formation of reactant. Okay, as the way I would say, just quote unquote, and so as the reaction is written in the above, and this is almost like a final before and after story. So finally, you became product before you were reactant. So final minus initial, that is what is defined as a delta H. So let's try to figure it out. Delta H for product. So that's a 1, which is involved with product with delta H of water, formation of water. And then there are 7 of them, so multiply by 7. And plus 6 of CO2, so delta HF CO2, which is I think to make sure it's a gas, and that information is correctly given. And so this is a 7 times water information, heat of formation of water, minus 241.9 kilojoule per mole, and this is 7 mole. So the mole signs are gone. What is surviving here is a kilojoule. Okay, so this is, I just wanted to make sure it's clear. This one is actually ended up having the kilojoule as a unit, and there's nothing as a per mole basis survive in this term. And 6 times, now what's the CO2 minus 393.5. Okay, so that will lead me to the formation is minus 53.6 kilojoule. Okay, remember that there is no mole is left there. Okay, so what about the reactant? The heat of formation of reactant products. So the reactant is hexane, and hexane is as it is, so 1 times, what is the heat of formation, minus 166.9, and that is the end unit is a kilojoule now, and plus water, the oxygen, 9.5 multiplied by this. So that is a big question now. What I need to write it now. Maybe I should write it. So delta F formation for O2 gas, right? So I need that information, and then wait a minute, where do I have those information there? This is not clearly emphasized, so let me write it clear. Okay, so this is, I need a heat of formation for O2, and this is once again now the O2 is a pure element, and it's in the and then the oxygen is in the gas in the is in the at the standard state, and so O2 is a gas in STP. So therefore, it's actually, you can imagine yourself as an imaginary table here, which is an O2 gas, which is a pure element. That is a zero. Okay, so this is actually the most key concept that you should keep that in mind. So therefore, this calculation is now easy, which is this is essentially just a zero. So then all I need is minus 166.9 kilojoule. Then all I need to do, delta H reaction is delta F formation of product minus delta F formations, all of them for reactant. Okay, so therefore minus 4353.6 minus minus 11166.9, and you will have minus 3886.7 kilojoule. Okay, so that is what is the delta H for reaction for this combustion of hexane, and this is the answer for that particular problem. Okay, so using what is called the standard enthalpy formation, and that is the answer. Thank you for your attention.